talk a lot. I'm sorry. You can always stop me and say it's enough. Okay, 58. 58. Very good. I'm looking at 190, right? That's what it is. Very good. I'm assuming is this problem correct? 58, right here at the bottom? Okay, very good. A manufacturer produces bolts of a fabric with a fixed width. Fine. The quantity Q of this fabric measured in yards, I take notes. Q in yards, okay, is a function of the selling price. Nice. So it's Q of P, where P is selling price. And of course, P is in dollars per yard. So every time I read the problem, I make some notes. So far I know that I have a function that is Q. I know it's measured in yards. I know that Q depends on the price, and price is dollars per yard. That's what I know so far from the first sentence. So we can write, indeed, Q equals a function of P. So that's what we're going to write. Indeed, Q is a function of P. Okay, let's read on. Then the total revenue earned with selling price P, so the revenue, oops, it's not of R, sorry, I'm going to erase that. So R of P, of the price, is the price multiplied by Q. Price times the number of yards, because Q is measured in yards. So it's P times Q. So let me clear that. I meant to write R of P, not R of R. Okay. So these are, again, only notes. We haven't done anything yet. Part A. What does it mean to say that F of 20 equals 10,000? Remember, F of 20 equals 10,000. One more time, Q is the quantity. I should have mentioned that. Q is quantity. So when the price is measurement unit per yard, the quantity that we produce is, I think it's yards because it's fabric. Let me check. The quantity Q of this fabric measured in yards. Very good. And now we are asked to find, or explain, I should say, what F prime of 20 equals negative 350 means. When, no. When P equals $20 per yard, what is this? What is the definition of F prime? The rate of change with respect to, I would say, I want to be specific, the rate of change of quantity with respect to price. The rate of change of quantity with respect to price, with respect to WRT, with respect to price, decreases at that instant by and I need number and measurement unit. By 350, what? Yes, per? Exactly. Yards per dollar. Very good. It's the rate of change of quantity over or with respect to price. So if you want yards per dollar per yard, price per unit. Okay, part B. Assuming the values in part A, find, so in part B, they want us to find R prime of 20 and interpret your answer. Perfect. Thank you for picking this problem. Thank you. So what did we say a minute ago? I'm asking you to find R prime of 20. What will you say? Wait a minute. I have to find what first? That's it. In this case, R prime of P, but it's exactly the same. Same idea. I really like this here. So I can put my stuff on it. Perfect. Okay, so I have to find R prime of P. And this is R prime. Look at what we have on the right-hand side and say, oh, I know this is a... Very good. It is a product. This is function 1 and this is function 2. Awesome. So let's find R prime of P. First function prime. 1. It's the variable. It's exactly what you said, x, but now we use P. So when I differentiate P or x, I get 1 times the second function. Plus the first function, P, multiplied by the, okay, we forgot the product rule. Hold on, hold on, hold on. We cannot forget this, right? We just reviewed it a second ago, so let's do it again. First prime times 2 plus first times 2 prime. So please remember the product rule. So coming back here, so this was 1 and this was 2. 1 prime is 1 times 2, which is this. Now I copied plus. I copied the first function, which is P, times what? Very good. It's the same thing, but we normally say f prime of P. But that's pretty much the same thing. Okay, at this point, I can determine this. Can anyone dictate? Did I pick this problem on the checklist? Okay, I'm not as smart as I thought. I should have. It's a good problem. Thank you, Robbie. Very good. Plus? Right, but let's write it for everyone to see first, and now we can plug in everything. Perfect. So f of 20. I go back to my notes. I have f of 20 to be indeed 10,000. So then I will replace by 10,000 plus 20 times f prime of 20. It was given to us, which is negative 350. So I multiply by negative 350. So I get 10,000 minus 7,000. So this is 70 and 2 zeros. Perfect. So this is 3,000. First of all, the measurement unit. And then what it represents, or if you want what it represents first, and then the measurement unit, it doesn't matter. So this is the how do I start? When I look at this symbol, it's the Perfect. So this is the rate of change of revenue with respect to price when dollars per yard. So the rate of change of revenue with respect to price when the price is this is, so I can put this in parentheses. So the rate of change of revenue with respect to price, of course, when the price is 20, is, okay, now the measurement unit. It's the rate of change of revenue with respect to price. Yes, please, Nick. Yes, dollars per. So that's the revenue. And now price is measured in dollars per yard. So very good. Good pick. Anything else? Thank you. Anything else? Anything else? I think I forgot about you. Okay. Anything else, or we continue with 3.4? Anything else once, twice, sold. So 3.4. The chain rule. This is exactly what Tom was asking 5 minutes ago. He said, okay, how do I know how to differentiate sum, a product, a difference, and a ratio. But what happens when I have a function composition? Function composition. Thank you. Okay, by function composition we mean f comp g of x. Very important to establish a few things here. Which of these two functions is a so-called inner function? Of course. So this is the inner. Obviously, the other one is the outer. So knowing that, this equals f of x. As we see, g of x is the inner, and f of x, or f, is the outer. Now, I want to point out two things here. Let's suppose we are given a function, and that is f of x equals 1 over x squared plus 1. I would like you to come up with, and there is more than one correct answer, I would like you to come up with an inner function and an outer function, such that when I plug the inner in the outer, I get this function. So what would you think would be an example? There is more than one correct answer. What would be the inner?
X squared plus 1.
Exactly, right? This would be the inner. Once I get a number, just one number, what is the outer? That's it. Because I plug in x squared plus 1 in 1 over x. And that's how I get this function. This is called function decomposition. We decomposed the function into an inner and the outer. Now, coming back to what we are discussing, because I want you to understand the difference. And you can say they're not the same. Here you will differentiate, and here we are talking about the function decomposition. The point I'm making is, when we decompose a function, we go from the inner to the outer. But when we differentiate, we go from the outer to the inner. That's why I presented this. You can say it has nothing to do with that. In a way, it doesn't. But I just want to explain When we decompose a function, we look at the inner and then go to the outer. But when we are going to differentiate that, we will differentiate the outer first and then the inner. Ready? So, f comp g of x prime is the same with f of g of x prime, because these two are the same. So the answer would be the outer prime times the inner prime. And you can say, oh, okay, well, why can't I reverse them and write g prime times f prime of g of x? You can. But again, I recommend keep a particular order that you're comfortable with, so then you don't make mistakes. Okay, I want to give an example. Let's say we have a sine of x squared minus 3x plus 2. And we want to differentiate this. Which one is the outer and which one is the inner? And you can say there is more than one correct answer, and I will have to agree. But which one is the outer? Sine. Which one is the inner? Or whatever, the quadratic function. So when I differentiate, first I have to differentiate the outer of the argument. But that doesn't change. So when I differentiate sine of this prime, I get of x squared minus 3x plus 2. And this is this piece. Now, multiplied, be very careful. There is no addition or subtraction in the function composition prime. This addition and subtraction may come from adding and subtracting and functions and differentiating that. From the product prime, from the quotient prime, not here. I've seen it very often. Students write plus or minus and differentiate this. Just please understand that this is a product. So times, obviously,
2x minus 3.
yes. Like with square root, we really don't like to put an expression like this after cosine. Because you may think, oh, I have to multiply these two to find cosine. No. So this is now goes in front just for simplicity. So we don't write the square root of x times 3 because we may be tempted to do this. So the same thing with cosine. So we will put 2x minus 3 in front and then cosine x squared minus 3x plus 2. And no one can further simplify this. So this is the chain rule. Now, before we choose problems from the book, there is a very important combo. So the combination or combo of power rule and the chain rule. The combo of power rule and the chain rule. Okay, let's see how we address this. Okay, so let's go back to the simple derivative from last time, in which we said, let's say x to the nth power. This was basically the first rule we looked at last week. And we said this equals n times to the, very good. And what I didn't tell you, I should have multiplied by x prime. The reason I did not do it is because x prime is 1. But this is the correct answer, times x prime. But it happens that it's 1. Now, instead of plain x, we will have a function, like sine, cosine, tangent, x cubed, whatever, to the nth power prime. All I want you is to mimic this, because if you see it as a comparison, I'm hoping you will not forget the rule.
So n times f.
That's it. And this is the combo of the chain rule and the power rule. One more example, and then I'll let you pick whatever you want. What about this? What does this equal to? Very good. Very good. Yes. But in order to be correct and exact, right. But we did not write this because it's 1. And it's a plain function, simple function. Okay. Now I want you to mimic this. And we have to remember it. Like we remembered 1 over 2 the square root of x. What will you say?
1 over 2 times square root of x.
Very good. This is still the same thing because the square root of x, the square root of f is f to 1/2. So it's still the same rule. But since we remember this, this is the straightforward answer, or the shortcut if you want. Okay, that's it. Let's go to, and you decide what you want to see. And this is section 3.4. On page 205. So you may encounter log and exponential, I mean especially log and exponential to another power. I will do that when we talk about log and exponential again. So anything you would like from 7 through 46. Any problem from 7 through 46? See what catches your eye.
21.
21. I was just looking at it. That's awesome. 21. In 21, we have y equals x squared plus 1 over x squared minus 1, and everything to the 3rd power. Starting from now, moving forward, we have to introduce a definition, I should say, or a notation that we looked at, but we haven't used it yet. And here's the notation. F prime of x is the same with y prime, and is the same with the derivative of y with respect to x. In short, we say dy over dx. One more time, f prime, y prime, same thing, and the derivative of y with respect to x, in short, dy over dx. So I would like to start using this notation. This notation here is not necessarily useful. In the next section, however, this is extremely important. Okay? So I don't have to do this right now, so we can write y prime. Y prime means this differentiated. So this is a function raised to the 3rd power. So it's a combo of chain rule and a power rule. What do I have to write? Very good. So far, so good. So 3 times x squared plus 1 over x squared minus 1, everything squared. So this was done, but now I'm here. Very good. So times x squared plus 1 over x squared minus 1, everything prime. But now what do I do with this? So now this is no longer the chain rule. This piece. What is it? The derivative of a quotient or ratio. Very good. So we carry these two along. We cannot change anything. So I copy 3. I copy x squared plus 1 over x squared minus 1 squared. And now I remember how to find the derivative of a quotient. Let's start with the denominator because that has nothing to do with anything really. Very good. So now remember, if you're using what I suggested, it's going to be 1, 2, 1 prime times 2 minus 1 times 2 prime. the top function prime, multiplied by the denominator, which is x squared minus 1, and now I have to put minus. The top function times the denominator prime. So one more time. 1 prime times 2 minus 1 times 2 prime. Now the next step is extremely important. There is nothing I can do to this, there is nothing I can do to this, but I must simplify this as much as possible. I will not distribute. You can say, oh, you're going to get the same thing. True. But I want you to get into the habit of not distributing, but instead... Exactly. Thank you. I have two terms, and they have a common factor. If you get into the habit of simplifying or factoring and so on and so forth, you will make your life easier in the long run. So what is common to those two terms? And I want to pull it out. Yes, indeed. And what is left? That's it. Awesome. Which is so much easier. You can say, well, really, there were just two terms. I would have to agree. It would not make a huge difference. I will multiply 2x by 3 because they're all factors. So I have 6x in front. Then these two will go away. I will still have a negative 2 that I will bring in front in a minute. So this is x squared plus 1 over x squared minus 1 to the second power. Again, negative 2 over x squared minus 1 squared. If you want, you can rearrange this. Can anyone tell us, other than multiplying 6x by negative 2 and getting negative 12x, what else can I do? Copy the top as
x squared plus 1 squared over x squared minus 1 squared. Oh, to the pool.
Extremely useful for chapter 4. So factoring is extremely useful. Rearranging all this into a fraction, very useful. So what's the big deal in chapter 4? Let me just give you the heads up. This is the big deal in chapter 4. Solving this equation. And this is so much easier. This will never be 0. X squared plus 1 never 0. So what is the only solution for f prime of x? Being 0. X equals 0. There's nothing else. This is never 0. This it better not be. It better not be, right? Because the denominator cannot be 0. So the only chance for f prime of x to be 0 is x equals 0, which is so much easier to see. So that's the big deal. You don't have to worry about this at this moment. That's for next chapter. Good pick. Anything else from here? Let's look at 34. So we have y equals x squared times e to negative 1 over x. We're asked to differentiate or find y prime or find dy over dx, the same thing. I look at this function and I notice what? That the function is a yes, also, but it's definitely a product first. And yes, e to this. Before we continue, let's look for a second at e to the x. So I'll come back to that. So what did we say about e to the x prime? We said e to the x, to be exact, it should have been no e prime is 0, times the inner function, this is the outer, because first I have to evaluate this, and then I apply it, I apply that number to e, or I apply e to that number, to be exact. But we did not use this. So what do you think about this? E raised to a function, not plain x. You can say, but x is a function. True. But anything else but x. What will be the answer? That's it. Okay. So now I have 1 times 2. It is a product. The first function prime times the second one plus this first function prime, and now let's take the derivative of this aside for a moment. E to negative 1 over x prime. It's exactly this. So what do I write first? Let's write it first for everyone to see, and then we'll determine it. Very good. In the past, we said, let's commit to memory, not the negative 1 over x, but commit to memory 1 over x prime. What did we say?
1 over.
With negative. Negative 1 over. That's the square root. So remember, this is x to negative 1. Negative 1 in front times x to negative 2. So negative 1 over?
2x squared.
Just x squared. Good? But now I have a minus here. What will change? That's it. So this will be 1 over x squared. So the derivative of this is, you can write it in several ways. You can write it as e to negative x divided by x squared. Or you can write it as 1 over x squared e to 1 over x. Whatever you want. But I haven't finished. Since I have e to negative 1 over x, I'd rather keep that. So I'm going to keep this as e to negative 1 over x multiplied by x to negative 2, or if you want the fraction. You prefer the fraction, which is this over this, or you want x to negative 2. It doesn't matter. Okay, now let's look at this. Very important to be able to simplify this expression. Now, when I multiply x squared by x to negative 2, assuming x is not 0, what do I get? Exactly. Copy the base, add the exponents. I get 0 for the exponent. X raised to 0 is 1. Of course, assuming x is not 0. It cannot be 0. It would have been in the denominator. Perfect. So now I have 2x e to negative 1 over x and plus e to negative 1 over x. What would you factor out? What is left in parentheses? And it happens that in chapter 4, we're going to set this equal to 0. How much is x? Negative 1/2. So this will never be 0. It's in the denominator. 1 over e to 1 over x is never going to be 0. So 2x plus 1 is 0. I move 1 and divide by 2. When we get there, no worries right now. Any questions? Any questions? Okay. Do we need more examples of this type before I look at others?
Yes.
Yes? Yes, of course. 41 caught my eye, unless you want to choose. Anyone wants to choose? Okay, well, 41. F of t equals sine squared of e to sine squared t. Uh-oh. How many functions we see here? Now, please give me the inner function. The inner function is?
Sine squared.
Of course, this one. The next outer, the first outer function, if you want, is e to sine squared. Okay. The next outer function is sine of that, sine of this. And the last one is power 2. 4 functions. Actually more, but at least 4. This is number 1, the innermost. This is the second one. This is the third one. And this is the fourth one. So f prime. Where do I start?
The outermost function.
Exactly, which is?
X squared.
Exactly, power 2. This one. This is the outermost function. What do I get? Times. I have to subtract 1 from the power. So sine of e to sine squared t times. So I started with the first one. I brought 2 down. I subtract 1 from the power. Now I have to differentiate the inner function. I only differentiated the power. Now I have to differentiate the first function. How much is this? Prime. Always remember, it's always all product. So multiply by cosine of 2 sine squared t. Okay, so now, one more time, I dealt with this, which is the outermost. I dealt with this, which is the next in line. Now I need to deal with this. How do I differentiate e raised to a function? It's e to that function times the derivative of the innermost function. How do I differentiate sine squared? Multiplied by, I have to bring the power in front. I have to subtract 1 from the power. And now I have to differentiate the inner function, which is multiplied by cosine t. Not a trivial problem. Let's do this again. When I want to evaluate this function, what will I do first? Let's say I'm asking you to evaluate for 5 radians. You will first plug it in sine. You will get a number. Then you will square it. You will get a number. Then you will apply e to that number. True? Then you will apply sine to this number. And then you will finish by squaring it. That's why I showed you the function decomposition so you understand how to differentiate. Okay, one more time. So if I want 5 here, then I have to determine sine 5. Then I square the answer. I get 15. E to 15, I get 10. Sine of 10, and then I square sine of 10. So the power first, sine, the inner, which is also a function composition, times the innermost prime. So one more time, the power was here, times the power minus 1. Now I differentiate sine, which is cosine of this. Now I differentiate this, which is e to that times the inner function prime. But that is also power function with the chain rule. 2 times sine t times cosine t. The only thing I can do is just put the 2 with the 2 and put e to the x, e to sine squared here, and the rest I can't do anything about. So this is 4 e to sine squared t. Let me put these 2 in front, times sine t times cosine t times these 2, and I can't change anything. Sine of e to sine squared multiplied by cosine e to sine squared. Yes, this was not a trivial problem. Any questions? I think I assigned problem 26. I would like to show a similar problem with 26. and we can make it up ourselves. So let's make it up. So I will write similar to 26 on page 205. Okay, question. Do we understand this answer? Yes? So when in doubt of how many functions you have and how many factors here, always say, okay, if I evaluate for, where do I start? Where I start with this and then this. Then I get a number, and then this e to that number. Then I apply sign to this number, and then I square that answer. When in doubt, decompose the function first. Okay, so here's what I would like to look at. So let's say 2x plus 1, everything to the 4th power. And the denominator is 3x squared plus 2, everything to the 5th power. It's a mess. And we want to find y prime. Why is it a mess? Because the function at the top, this is a function composition. The outer is power 4, and the inner is 2x plus 1. Also, the denominator is a function composition. The outer is power 5, and the inner is 3x squared plus 2. Since it's a ratio, I can already write the denominator very easily. There is nothing I can do there. What is the power? Very good. Copy the base, multiply the exponents. Perfect. Okay, so let's differentiate the top. I have to differentiate the power first. So it's 4 multiplied by 2x plus 1 to the 3rd times the inner function prime, 2, multiplied by the 2nd function. Now minus. And you already noticed I will run out of rooms very soon. I copy the top and multiply, and I'm put a arrow. I'm going to put the derivative prime up here. Sorry. I would have stopped if the inside were x alone. But it's not x alone, so I have to multiply by. Yes, which is? Very good. Very good. I'm going to write it one more time, so I have everything in one fraction. And then you will tell me what to do next. Oh, this is not a good color. So then I have y prime, which is 4 times 2 in front, 8. 2x plus 1 to the 3rd. 3x squared plus 5 to the 5th. 6x times 5 minus 30x times 2x plus 1 to the 4th. I can put everything in one. So, and then multiply by 3x squared plus 2 to the 4th. And everything divided by 3x squared plus 2 to the 10th. Identical situation with the previous case, in which I have no choice but. Yes, I can pull out what? So this is 8 and this is 30x, nothing in common. Now I'm looking at these two. So I pull out a 2x plus 1 to the power. Very good. And I also see the 3x squared plus 5 to which power? I'm very good at that. Very good at that. Very good. Thank you very much. Okay, so to the 4th. And now careful. 3x squared plus 2 to the 10th power. Careful now, this is crucial. Now I can do this. I remove 4 from the top and 4 from the bottom. I could have not done that before factoring. I cannot simplify terms. or pieces of parts of terms. I have to simplify only factors. Okay, so let's see where we have left. This is completely out. 8 is left in. And from these 5, I removed 4 of those. So what is left in parentheses? Yes, a 3x squared plus 2. I reached the negative sign. Let's stop for a moment. Is this clear, everyone? Okay, the next step, I have the 30x. From these 4, I took out 3. So what is left in parentheses? 2x plus 1. Of course, as you see, I can fit everything. And this is completely out. Finally, 2x plus 1 to the third over 3x squared plus 2 to the sixth. 8 times 3x squared. Plus 16. Negative 30 squared minus. Yes, I will combine like terms and arrange this polynomial in descending order, and I will factor out the negative leading coefficient. So this is 2x plus 1 to the third. Negative 60 plus 24 is very good. Then I have to write the negative 30x, and then I have to write the 16. And I will factor out the negative leading coefficient and also what is common to these 3. Only 2. So 2x plus 1 cubed, and let's see what we have left. A lot of work. So it is 18x squared plus 15x. That's it. Okay, so let's look at a couple of other types of problems.